So the third lesson on this chapter is called Data Collection and Experimental Design. For this section, we have these four objectives. We want to learn how to design a statistical study and how to distinguish between an observational study and an experiment, how to collect data by using a survey or a simulation, how to design an experiment, and the last one is how to create a sample using random sampling, simple random sampling, stratified sampling, cluster sampling, and systematic sampling, and how to identify a bias sample. First objective is designing a statistical study. First step will be identify the variables of the interest, the focus, and the population of the study. What is the variable that you are interested in? Number two is develop a detailed plan for collecting data. If you use a sample, make sure the sample is representative of the population. Third one is collect the data. Fourth one is describe the data using descriptive statistics techniques. Fifth one is interpret the data and make decisions about the population using inferential statistics. And six is identify any possible errors. Observational study. A researcher observes and measures characteristics of interest of part of a population. Researchers measure the amount of time people spend doing various activities such as paid work, childcare, and socializing. So if a researcher is measuring the amount of time that people are spending for these activities, this is an observational study. However, an experiment is a treatment is applied to part of a population called a treatment group, and responses are observed. Another part of the population may be used as a control group in which no treatment is applied. The subjects in both groups are called experimental units. In many cases, subjects in the control group are given as a placebo, which is a harmless fake treatment that is made to look like the real treatment. An experiment was performed in which overweight subjects were given the artificial sweetener sucralose to drink while a control group drank just regular water. After performing a glucose test, researchers concluded that sucralose affects the glycemic and insulin responses in overweight people who do not normally consume artificial sweeteners. So determine whether each study is an observational study or an experiment. So after we talked about what an observational study and what an experiment is, now we will have two sentences and which we will decide which one is the observational study, which one is the experiment. So the first one, researchers study the effect of vitamin D supplementation among patients with antibody deficiency or frequent respiratory tract infections. 70 patients received 4,000 of vitamin D for a year. Another group of 70 patients received a placebo daily for 1 year. So the study here applies a treatment to the subjects. So this study is an experiment. So here we're going to decide if each of these statistic sentences are observational study or experiment. And then on the first one, it will be an experiment because they're actually applying a treatment here, which is a vitamin D. When we look at the second sentence, researchers conduct a study to determine how confident Americans are in the economy. Researchers call 3,040 US adults and ask them to rate their current economic conditions and whether the economy is getting better or worse. Now, in order to decide if this is an observational study or an experiment, let's ask this question. Are they given any treatment in this study? So the first question was, it was applying a treatment, so it was an experiment. When we look at the second sentence here, this study does not attempt to influence the responses of the subjects, so this will be a complete observational study. When we look at the data collection process, we have something called simulation Simulation is using a mathematical or physical model to reproduce the conditions of a situation or process. And simulations usually involves the use of computers, and it allows you to study situations that are impractical or even dangerous to create in real life. And simulations, they often save time and money. For example, automobile manufacturers, they use simulations with dummies to study effects of crashes on humans. Survey. This is another technique for data collecting. An investigation of one or more characteristics of a population. Surveys are carried out on people by asking them questions, commonly done by interview, internet, phone, or mail. And in designing a survey, it is important to word the questions so that they do not lead to the biased results, which are not representative of a population. For example, a survey which is conducted on a sample of physicians to determine whether the primary reason for their career choice is financial stability. In designing the survey, it will be acceptable to make a list of reasons and ask each individual in the sample to select their first choice. So now when we look at the experimental design, which will have 8 parts, 3 key elements of well-designed experiment are control, randomization, and replication. These are the 3 key elements of a well-designed experiment: control, randomization, and replication. Second, confounding variables. It occurs when an experimenter cannot tell the difference between the effects of different factors on a variable. For instance, a coffee shop owner remodels her shop at the same time a nearby mall has its grand opening. If business at the coffee shop increases, this person cannot decide whether it happened because of a remodeling or it's because of the new mall, and this is called confounding variables. Confounding variables. The placebo effect occurs when a subject reacts favorably to a placebo when in fact the subject has been given a fake treatment. To help control or minimize the placebo effect, a technique called blinding can be used. What's a blinding? Blinding is a technique in which the subjects do not know whether they're receiving a treatment or a fake treatment. Double blinding experiment, neither the subject nor the experimenter knows if the subject is receiving a treatment or a placebo. Fifth, randomization, a process of randomly assigning subjects to different treatment groups. Completely randomized design. Subjects are assigned to different treatment groups through random selection. Randomized block design divides subjects with similar characteristics into blocks, and then within each block, randomly assign subjects to treatment groups. And then key elements of experimental design for randomization, randomized block design. An experimenter testing the effects of a new weight loss drink may first divide the subjects into age categories. Then within each group, randomly assign subject to their either treatment group or control group. Matched pairs design. Subjects are paired up according to a similarity. One subject in the pair is randomly selected to receive one treatment, while the other subject receives a different treatment. Sample size. The number of subjects in a study is very important to experimental design. Replication. The repetition of an experiment using a large group of subjects. For instance, to test a vaccine against a strain of influenza, 10,000 people are given the vaccine and another 10,000 people are given a placebo. Because of the sample size, the effectiveness of the vaccine would most likely be observed. So when we look at now experimental design example, a company wants to test the effectiveness of a new gum developed to help people quit smoking. Identify a potential problem with the given experimental design and suggest a way to improve it. So here's what they're doing. The company identifies 10 adults who are heavy smokers. 5 of the subjects are given the new gum, and the other 5 subjects are given a placebo. After 2 months, the subjects are evaluated, and it is found that the 5 subjects using the new gum have quit smoking. Okay, so we're gonna find the problem here. So let's look at the problem. Here the problem is, if you remember, it's 5 people taking the gum, 5 people not taking the gum. The sample size being used is not large enough to validate the results of this experiment. The experiment must be replicated to improve the validity. This will be the correction here. Okay, again, another experimental design. The company identifies 1,000 adults who are heavy smokers. The subjects are divided into blocks according to the gender. After 2 months, the female group has a significant number of subjects who have quit smoking. So what is the problem now with this experimental design? The groups are not similar. The new gum may have a greater effect on women than men, so you can't just make a general statement about the gum. The subjects can be divided into blocks according to gender, but then within each block, they must be randomly assigned to be in the treatment group or in the control group to decide the effectiveness. Now we're going to look at the sampling techniques. And before we look at the sampling techniques, we're going to learn some keywords. A census is a count or measure of an entire population. A sampling is a count or measure of part of a population and is more commonly used in statistical studies. Even with the best methods of sampling, a sampling error may occur. A sampling error is the difference between the results of a sample and those of the population. Sampling techniques. We have random sample and simple random sample. Random sample is every member of the population has an equal chance of being selected. Simple random sample, every possible sample of the same size has the same chance of being selected. So every member of the population has an equal chance of being selected. Every possible sample of the same size has the chance of being selected. Random numbers can be generated by a random number table, a software program, or a calculator. Assign a number to each member of the population. Members of the population that correspond to these numbers become members of the sample. Using a simple random sample. Here's an example. There are 731 students currently enrolled in statistics at your school. You wish to form a sample of 8 students to answer some survey questions. Select the students who will belong to the simple random sample. Assign numbers 1 through 731 to each student taking statistics. On the table of random numbers, choose a starting place at random. Suppose you start in the 3rd row, 2nd column. 3rd row, 2nd column. Read the digits in groups of the 3. Ignore the numbers greater than 731. So for example, here, this is the random numbers table. Although it's 5 digits, so they take the first 3 digits and then ignore the last 2 digits. The students assign numbers like 719, 662, 650. This would make up the sample. Other sampling techniques. We will look at some other sampling techniques like stratified sample, which means divide the population into groups, which we call strata, and select a random sample from each group. To collect a stratified sample of the number of people who live in Westridge County households, you could divide the households in the socio-economic levels and then randomly select households from each level. So group 1 is low income, group 2 is middle income, group 3 is high income. So we have 3 different strata here. And then from each strata, if you just randomly select some households from each level, this will be called stratified sampling. Next sampling type is called cluster sample. Cluster sample is when you divide the population into groups. So you can simply say that these are the clusters, and then you select all of the members in one or more but not all of the clusters. For example, the example would be West Rich County example. You could divide the households into clusters according to the zip codes, then select all the households in one or more, but not at all zip codes. So zip code zones in West Rich County, this is an example for the cluster sampling. Next sampling technique is called systematic sample. Choose a starting value at random, then choose every case member of the population. In the West Rich County example, you could assign a different number to each household, randomly choose a starting number, then select every 100 household. Randomly choose the starting number, then add 100 to this number all the time, select every 100 house. This is called systematic sampling. Last sampling technique is called convenience sampling. Choose only members of the population that are easy to get, and this often leads to a biased studies, and this is not recommended. So let's take a look at an example to decide what kind of sampling is happening in each sentence. You're doing a study to determine the opinion of students at your school regarding stem cell research. Identify the sampling technique used. You divide the student population with respect to measures and randomly select and question some students in each measure. This is called stratified sampling because students are divided into strata, into measures, and then a sample is selected from each measure. So this is called stratified sampling. Second sentence, you assign each student a number and generate random numbers. You then question each student whose number is randomly selected. This is called simple random sample because each sample of the same size has an equal chance of being selected and each student has equal chance of being selected. So this is called simple random sample. Third example here is you select your students who are in your biology class. So this is a sample taken from the students that are very heavily available to you. And this is called convenience sample. The sample may be biased because biology students may be more familiar with STEM cell research than the other students, and they might have stronger opinions. So this will be a biased, convenience sampling. So if you just quickly look at these sampling techniques again before we finish the video today. So we have simple random sample, right? Let's just go here. So we have the random sample, simple random sample technique, which is simple random technique just uses the random number generator. Other sampling techniques are stratified sample, cluster sample, systematic sample, and convenience sample. This is all for this section. Thank you.